Hello, grade 11 students. Welcome to grade 11 University Math, MCR3U. We're just going to run through this short lesson today on a couple questions that I want you to think about to get in the right frame of mind for how to do math at a higher level. Ultimately, that's what the purpose of this course is to go on in mathematics. You might not need it because you want to be a math major, but you might need it for something else. And so we want to start to encourage you to think about math on a deeper level so you can be as successful as possible. There's a lot of things we do in class this day, like we go on the computers, get you acquainted with the website, make sure that you know how to access the course notes. But the big thing that we want to do today is talk about these questions, get you in that right frame of mind. So just going to look at a few questions to start here. So the first question is, why are mixed fractions better than improper fractions? So these are things that we learned in elementary school. Improper fractions, we converted everything to improper fractions. We left them like that, and we thought that was great. But there's also a need for mixed fractions as well. And mixed fractions are going to be, we're going to see fractions throughout this course, but in a bit of a different way. And so now we're not going to have fractions in everything we learn. We might not even have to worry about them for certain things, like they do create a higher level of difficulty. But we are going to have to understand the ideas of fractions. And so first thing is like how to actually graph them. So we asked this question, what is 8 minus a quarter? And so I know a lot of you guys would stop this and we'd say, like, well, it's 8 over 1, and then I got to make a common denominator, if you remember that. We're going to multiply the top and the bottom by 4, so we get 32 over 4 minus 1 over 4, so it's 31 over 4, and then we deal with it accordingly. But my point to you is to think about this differently. 8 minus a quarter, a lot of you guys, or most of you, should be able to visualize this. And when you see the answer, like, it really does make sense. So if we have 8 minus a quarter, the answer is 7 3/4. That is in fact 31 over 4. It's the same thing. However, we did that with not just saving steps, but really thinking about what the question's asking, rather than just going back to a process. Okay, and that's what I want to encourage you here. It's just a small example. We will use things like this. So 7 3/4 is easier to graph than 31 over 4. We certainly need like the fraction of the decimal and mixed fraction and mixed form, or the decimal. But it's easier to graph. It's easier to estimate what 7 3/4 is. What is the same different about solving for x in each of the following? So you need to kind of look at this, and so some of the things, whenever I ask you what's the same and different, you can first start out by saying the obvious things. Like, there's obviously a 10 on both sides, there's a 1 on both sides. But about solving for x, so what's the process? So two important things I wanted to do here was talk about the idea of same and different. And so we just organize that and say, well, this is the same, this is different, and then we encourage ourselves to think a little bit deeper. So what's the same? We subtract 1 from both sides. That's how we solve an equation. We don't just move the plus 1 to the other side and make it minus 1. We can do that because it's an equation in balance, and we subtract 1 from both sides. So then you get 9 on both sides. And so you've got these obvious things like the 10, the 1, they become 9. And so what's different is the first one equals 9, and the second square equals 9. Okay? And so we're saying like something that it's very similar, but that's what makes them different. The first one has one answer. The second has 2. This was kind of like a purpose of this question, was to start to like uncover this. We've seen things like this in Pythagorean theorem, where there's one answer, and we just take the square root of 9 and we get 3. But certainly there is 2, and I invite you to think about what the second answer is. So one's a positive, one's a negative, and the two answers are plus and minus 3. Okay? And so this is actually going to come up in conversation, so we want to make sure, and plus minus, we've seen that in the quadratic formula from grade 10, and we're certainly going to see that again in this course. But that plus minus 3 is I really want to talk about that today. Then what does x squared plus y squared equals 25 look like? And so I just ask you to like do that. You can pause the video and think about it. What does it look like on a graph? We've seen what a line looks like. We've seen what a quadratic looks like. But what does x squared plus y squared equals 25 look like? Some of you may or may not have experience with something that looks like that. And even if you do, you might have forgotten because it's been a while. So I'll give you a couple hints after if you want to think about it. And you can pause it throughout, or you can just jump right into the hints. Try entering different values for x and solve for y. So try entering different values for x and solve for y. Which ones would work nicely? So do you want to just plug in anything for x? Do you want to plug in 1 for x, 2 for x, 3 for x? Which ones would work nicely? And then use a table of values and plot the points. And then we can explore with Desmos. And so I'll actually show you this because this is something that I didn't have when I was in high school, and it's just incredible, and we're going to use it throughout this course. And it's just such a great resource because there's apps on your phones for this, and certainly you can access this from any computer. So we're gonna click on this link here, and we're gonna go to something called Desmos. And what it is you just go to desmos.com or follow the link, and it's actually a free graphing calculator. It allows you to do a lot of cool things. And so what we're gonna try to do here is you can enter the functions into the left. And I'm going to use x squared. So I just use a little hat above the 6 if I want to use the keyboard, but you can also use this function here. Plus y squared equals 25. You can get rid of the keypad. We can zoom in and zoom out. With a mouse is easier. Certainly with your fingers on a phone is easier. You can put in projector mode so you can see it bigger. That's what we would use as teachers. You can click on the key points, which if you were using a table of values, these are the points you would have subbed in: 5, 0, and -5. And then you get that idea, like if you solve for y, you've got that plus minus to give you 2 values. And so then you can see points all in between. I think like the nice ones are going to be if you have 4. 4 and 3 is a nice point. It doesn't stay on like the other ones, but you can play with this. And if you go to the function, you can edit it, and you should be able to convert it to a table. I guess because it's actually not a function, which we'll get to later. You can't convert it to a table, but you can certainly see all the points along. And so what this becomes is a circle. X squared plus y squared equals 25. So I'd ask you what the relationship is between the 25 and the circle, and certainly that is the radius. So if I change it to 20, it doesn't really have a nice radius of 4.472. But if I change it to something like 16, then you've got the radius of 4. If I change it to 9, you've got the radius of 3. It's a really nice graphing calculator. You can see like things change instantaneously. Even if I like delete this squared for a second, it'll give me a quadratic just for the time being. And so it is a really neat graphing program. There's graph settings, like you can set the x-axis, y-axis, whatever you want, although you can also zoom in and zoom out with the mouse or the keyboard, or your fingers if you're using it on a device. We can add more functions just by going between. We can plot points like 2, 3. So we can plot that point there, and we can see 2, 3 right there. So it's really neat, and we'll continue to use it throughout the course. Okay. So that's it for today. The practice for today is just, these are some skills that we didn't really talk about today necessarily, but I just want to check to see if you're still getting this, kind of like your review skills. Just to, I don't want to go too much into parabolas and things like that because we'll review those in Unit 3 and throughout the first 3 units. But if you can do the solving equations with fractions, if there's any that you're having trouble with, just come in and ask about, because you want to kind of take care of those things that you make sure you understand and take care of those early. Okay.